In this video, we're just going to do a few more examples on how to find the derivative using the definition of the derivative that we outlined in our last video. My first example is, it says f of x is equal to 2x. So what is the derivative equal to? F prime of x, the derivative. So in order to find the derivative, we'll use our formula, which says f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. This is the definition that we're going to keep coming back to. So let's try to figure this out. The first thing that I always suggest doing is finding f of x plus h. We already know what f of x is, that's 2x. But f of x plus h, it's always helpful to kind of do that off to the side. So f of x plus h is what happens when you plug in x plus h into 2 times x. In this case, it gets plugged in for the x, so we have 2 times x plus h in parentheses. Using the distributive property, we'll see that it's 2x plus 2h. So now we can continue our problem. It says the derivative is equal to this, and now we know what f of x plus h is. It's 2x plus 2h. We'll need to subtract f of x. That's just 2x. And that's all over h. We need to simplify this a little bit, so we'll have the limit as h approaches 0. The 2x's cancel out, and we have 2h over h. If we try direct substitution right now, we're going to get 0 over 0, so it's best to just cancel out these h's. And then we have the limit as h approaches 0 of 2, and we've already discussed that if you have a constant here, you can't substitute 0 into it, so the limit as h approaches 0 of 2 is just 2. Let's try another example. We have f of x equals x squared plus 3x. We want to find the derivative, f prime of x, and then we're also going to find the derivative at x equals 2. So the slope of the tangent line, the instantaneous rate of change, or the slope of the curve at x equals 2. We'll do this first by finding the general derivative using the definition that we've been discussing, and then we'll take that derivative and we'll plug in 2 to that later. But first, let's find the derivative. We've defined the derivative as the limit as h approaches 0 of f of x plus h minus f of x over h. It helps to tell what f of x plus h is, especially for a problem like this that's a little trickier. So let's find out, what is f of x plus h for this problem? It means plug in x plus h to anywhere you see x up here. So we're going to have x plus h squared plus 3 times x plus h. We have to plug in x plus h here and here. Let's simplify that a little bit. That's really meaning x plus h times x plus h plus, okay, and then distribute 3x plus 3h. Simplify this even more. We get x squared plus 2xh using foiling method plus h squared plus 3x plus 3h. Nothing here can be combined, but this is our f of x plus h, so it's a little bit lengthy for a problem that looks like this. So let's go ahead and plug this back in here for f of x plus h. We'll say the derivative is equal to our limit as h approaches 0 of this x squared plus 2xh plus h squared plus 3x plus 3h. Then we need to subtract our f of x, and we need to be very careful to do this using parentheses, because when you subtract f of x, it's really minus x squared plus 3x, all of that in parentheses. and then that's all over h still. Now we'll need to simplify this down. We'll say the limit as h approaches 0, and we can sort of block off this work we did over here. That was just to figure out what f of x plus h was. Okay, let's see, what do we have here? We're going to have this x squared minus this x squared. Those will go away. I'll go ahead and cross those out. We're also going to have this 3x subtracting this 3x. Those will also cancel out. And we're left with 2xh plus h squared plus 3h all over h. At this point, we could try direct substitution, plugging in 0 for h, but we'd end up with 0 over 0, which is our indeterminate form. So we'd have to do a little bit of factoring or canceling before we actually find what the limit is. So let's go ahead and do that. Let's actually factor out an h from everything. The limit as h approaches 0, we'll factor out an h from everything. Or you can just go through and cross them out. It's really your choice here. Over h. These h's will cancel. Let's rewrite this. And whether you factor it out or just go through and cancel an h from everything, you're going to get the same answer. At this point, we'll try our direct substitution again, plugging in 0 for h. This will not give us our indeterminate form. We'll actually get an answer here. So if you plug in 0 for h, you're going to be left with 2x plus 3. That is our f prime of x. We can say that's 2x plus 3. That is f prime of x. That is the general derivative to this question. Then I asked you, what's f prime of 2, or what's the value of this derivative at 2? And this is really easy once you know the derivative. You can just say f prime of 2 is what happens when you plug 2 into your derivative. So we'll get 2 times 2 plus 3 will give us 7. So f prime of 2 is equal to, we can change this question mark, to a 7, plugging in 2 to this function we found for the derivative.